Hello everyone, we're going to be making a line of BestFit, and to construct that we're going to take kind of what looks like the best, right? The line of BestFit. We're going to find what kind of looks like the best line that would fit this set of data. So the way that we do that, we need to get two pieces of information. Okay, so line of BestFit, you need two pieces of information. When you have a function that is a linear function that you've learned about in the last credit, that you need to get a rate of change and an initial condition to define that linear function. So the rate of change, we call it by many different names. We call it by slope or unit rate of change, or it's the multiplier on x, or we can think of it as a rise over a run, or it's the change in y over the change in x, or you can actually use the values of two different points. So comparing those points in the y direction over the change in x values, right? So it's the difference in y values of any 2 points over the difference in x values of any 2 points. So we're going to use kind of this understanding of what the rate of change is, because it's the same everywhere, right? We can pick any 2 points, find the change in their y values, and compare that to the change in the x values, and that will give us this piece of information. Okay, and then the other piece of information that we need is that initial condition. So we call that by many different names. The y-intercept. It's the y value when x is equal to 0. It's the function evaluated at 0. It's the constant term in this equation. So a lot of different ways to think about it, but I think it's probably easiest to think of it as the y-intercept, right? So it's just where that line is crossing the y-axis. So let me grab a rubber band, and let's just say something like this. So I need to get another peg to put on the board. So I'll just say that right there. Okay, so something kind of like that. And so my y-intercept, I would say, is -2. So that's that piece of information right there. That's my initial condition, is -2. And then the slope, so I have to pick 2 points. So maybe I could take this point and this point and find the difference in their y values. So let's see, it's going up by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's going up by 13 and over by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 13 over 10. So I could fill that in as it's going up by 13 over 10, and my initial condition is -2. So that would be the function of my line of best fit. So that's how you basically do it. Now let's take it to a little bit more difficult kind of a question. Okay, so this line of best fit, and the way I might do that is just take a ruler and kind of pick this out. Now there is a more scientific way to come up with this, but you probably won't be doing that unless you want to actually write a program for it. So I wouldn't worry too much about it, but we're just kind of looking with a keen eye on how to find that line of best fit. It doesn't have to be exact. So the two pieces of information that I need are the initial condition, right? So I can estimate that's around halfway between 20 and 40, so I'm going to say it's 30. So that's the constant term. And then my multiplier on x is the constant rate of change. So this is going to be a little bit more difficult, but let's just pick maybe a point at 30, and then we estimate that that second point maybe comes around more towards 60. I'll say 65. So this point right here, I'm going to call it the x value is 30 and the y value is 65. And then this point we already have, right? This is 0 in the x direction and 30 in the y direction. So I'm going to take the difference of these y values, which would be 35, right? 65 minus 30 will be 35, divided by the change in x value. So it goes from 0 to 30. So the difference between those two would be 30, right? 30 minus 0. So I might simplify this. Let's see, I can divide the top and the bottom both by a 5, right? So that'd be 7. And divide that by 5 would be 6. So this looks like a pretty good approximation of the line of best fit. So we'll call that f of x. Now, if I want to predict values that happen in the future, which is a pretty common thing with these lines of best fit, is to say, what would the value be at an x value of 100? So then you can just take that value and plug it into my function and find out what the prediction would be. So f of 100 equals 76 times the x value of 100 plus 30. And let's see, I'll just reduce this a little bit. Divide both by 2. And so 7 times 50 would be 350 divided by 3 plus 30. So 350 divided by 3 plus 30. And I might just punch it in my calculator. So 350 divided by 3 plus 30. I get 146.6, so I'll just round that to 147. So f of 100 is 147. So that would be my prediction of the value at 100. So if we go out to 100, I predict a value of 147 up here. Okay, so that's how you use those lines of best fit. And up next, we'll show you how to use that in GeoGebra.